All right, this problem is going to have us use an application problem in a system of equations. We're going to both write and then solve the equation with two variables. So we have two ticket costs, $50 for children, $25 for children, and $50 for adults. And we know that there's an attendance of a total of 2,000 people, and then we have a revenue of 70,000. How many children and adults bought tickets? So like looking at both of them. So let's call children X and adults Y. And that's what I don't know. I don't know the number of children tickets, and I don't know the number of adult tickets, right? That's what I'm trying to figure out. Well, I do know that X plus Y is 2,000. And I also know that the rate for the ticket is $25 per child ticket. And then the cost for the adults is 50. And if I add that all up, so $25 per child, $50 per adult, I end up getting 70,000 when I do that. All right, I'm going to choose to use addition method here. Actually, no, I'm gonna do substitution. So I'm gonna subtract X. And then substitute that in here for Y. So 25X plus 50 times Y, substituting that in, 70,000. Okay, so I have 25X plus, see, 10 and then 4 zeros, minus 50X. So I have negative 25X when I combine these like terms, and 70,000 minus 100,000 would give me negative 30,000. All right, let's divide 30,000 by 25. All right, and I get 1,200 for children tickets. And then that's super easy to plug back in here because I know the total is 2,000. So that means that Y must be 800 adult tickets.